Hello guys, welcome back to the channel. 2078 two furthest houses with different colors. It's when asked in Google Meta and Visa, and it's pretty easy to solve. Let's go through this problem statement. We have been given a colors array where the colors of I represent the color at that particular house. So what we need to do is we need to find the maximum distance between two houses having different colors. So if we go through this example, uh, we can see there are a lot of houses with color 1 and the house with color 6, and if we try to find the maximum distance between two houses having different colors, we will find this pair 0 and 3, and the distance will be 3. Okay, so the naive approach is like, what if we calculate all the pairs of I and j which satisfy this condition where color of I is not equal to color of j, and then we just calculate the maximum distance and return it. This will work, but in small test cases. In bigger test cases, this order of n square solution will break. Okay, so consider this thing. Whenever we are making a decision for any particular array element, the furthest distance can be calculated from the last index and the first index, because this distance will be maximum. If we calculate this distance, uh, this d1, d2 and d3, the at the end the decision will be made from this d1 and d2 only. If consider this case, we have taken an array with 3 elements only, but when we are making a decision to calculate the maximum distance, it will be between only this two elements. The decision can't be made between these two elements. We are not doing a classical two-pointer approach here, but uh, see, let's say we fix this left pointer at this index, and what this will do is it will just move to the right and see if array of left is not equal to array of 0, and calculate the distance and store it. Similarly, we will fix this right index, uh, iterate in the left direction and see if array of right is not equal to array of n minus 1, calculate the distance and store it. So both this distance will be calculated and maximum will be written. But whenever we at a position index j, at that particular index we can make the decision for both. We can see if the last index is not equal to the current index, and then we calculate the distance for it d1, and if the 0th index is not equal to current index, we calculate the distance d2, and then we can store the maximum. So in this case we can do both the computation of a single loop. Okay, so let's go through the pseudocode. So what we are doing is we are just iterating the array in the forward direction, and for any index we are checking if the current index is not the 0th index, then we can make a decision for d1. So d1 can be calculated as the distance from the 0th index to the current index. It will be I only, and if the uh, current element is not at a index n minus 1 also, we can calculate the distance d2, which will be n minus I minus 1. So we are storing the max of both, and at the end, when all iterations are completed, we are just returning the answer. Now the time complexity will be order of n, since we are just using a single loop, and two computations we are doing in a single loop only, and no extra space has been used, so order of n space complexity.